All right, welcome back to Geometry. Today we're going to be talking about. So, yesterday we did conjectures and we saw patterns, and then we had to decide what's going to be the next shape, figure, or number in the pattern. The next in the sequence was. So, we were using inductive reasoning to move from a pattern to finding out what the next, what's it called? It was the next part of the sequence, the next member of the sequence, I guess we could say. Today we're going to talk about counterexamples. So we're going to determine today whether a statement is true or false. A conjecture is false if there is even one situation in which the conjecture is not true. So the false example is called a counterexample. So that's what we're going to be talking about today. We're going to be talking about whether or not the conjecture that is given is a true statement or a false statement. All right, so find a counterexample to show that the conjecture is false. All right, if AB is congruent to BC, then B is the midpoint of AC. Okay, so what they're saying is, and this is where they're trying to lead you to, this is where I don't want to say trying to lead you to, but this is where you can get confused, is they never said that A, B, and C are coplanar, meaning that they're in a collinear. So they never said that they were collinear, and you would, if that were the case, if it said that they were collinear and congruent, then B would be the midpoint. But they never said that. In order for B to be the midpoint of AC, it needs to be in the middle in the line with it. But it never says collinear. Is it possible to draw a diagram where AB is congruent to BC such that B is not the midpoint? The answer is yes. So we have an angle here, right? AB is 3 centimeters, BC is 3 centimeters, but they don't line up. They're not collinear, right? And so this is called a counterexample. So this is called a counterexample. We proved by drawing this diagram, we proved that this conjecture is false. So if AB is congruent to BC, then B is the midpoint of AC. Is not always the case, because we have an angle here right now. AB is congruent to BC, but B is not collinear, so it is not a midpoint. So the conjecture is false. So that's what we're going to be doing today for your assignment. You're going to be determining whether the statement given is true or false. If it's true, it's true. You can't give a counterexample. If it's true, it's true. So you're not going to give it a counterexample. But if it's false, you're going to give a counterexample. You're gonna show why it's not false, why it's not true. So your worksheet is going to look a little bit different. I went and added a couple problems here to do as examples for you guys, but this is what you guys are going to have. You guys are going to have 4 problems to do on your own. So I'm going to do these 4 problems with you. So the movie recording messed up on me, so hold on, bear with me, guys. There we go. All right, so we're back. If angle ABC and angle CBD form a linear pair, then angle ABC is congruent or equal to angle CBD. So in order for us to do this problem, we need to remember what a linear pair is. So a linear pair are 2 angles. So I'll draw a linear pair are 2 angles that form a line. So angle 1 and angle 2 are a linear pair, right? So they're saying that angle ABC and CBD form a linear pair. So this is a linear pair. So let's see. If I put A here, B would have to be my vertex, B. and I put C here, that would be angle ABC. And then we have angle CBD. So what we have is ABC and CBD form a linear pair. Now the conjecture is that those two angles have to be equal. They have to be congruent. Well, if you look at my diagram here, my picture that I drew, you would see that angle ABC is obtuse. So that's obtuse. Meaning it's greater than 90 degrees. If we remember that, right? And then this angle here, angle CBD, is acute, which means it's less than 90 degrees. So in that case, are those two angles equal? No. So angle ABC does not equal angle CBD. So since I just gave a counterexample, I can say that this conjecture is indeed false. So you're thinking through the logical arguments of what we've been discussing this whole time. That's how we do this. You're thinking through the definitions, the things we've learned so far in geometry. So you have to put it all together now. If AB, BC, and AC are congruent, so they're all equal, then AB and C are collinear. So what they're saying is I have 3 line segments that are equal, and if that's the case, then they have to be in a line. They have to be collinear. So the thought would be this: if this is A, B, sorry, can't do that. So A, B, C. All right, so what I'm showing you is they're trying to say it's collinear, and I'm going to show you real quick. AB here could equal BC, but AC is the whole term. So just by that, by drawing the diagram of what they're kind of leading to, we realize that it's not going to work. But that doesn't count as a counterexample yet. We're not okay to count that as a counterexample yet. What we got to do is we got to show that they don't have to be collinear. All right? Because what we showed was AB equals BC, but we didn't show AC is equal yet. So we have to show all 3 sides. So what about this? If this is A, B, and C, if you notice, I just drew an equilateral triangle. All the sides are equal, but what do we know? They're not all in a line. They're not collinear. So collinear is out, and so our conjecture here is false. So you just have to come up with something that makes it that tells it's false. If AB equals B, or AB plus BC equals AC, then AB equals BC. So again, I'm going to draw a line segment. I'm going to say A, B, and C. Well, what if AB is 2 units and BC is 5 units? Then AC would have to equal 2 plus 5, which equals 7. So if you look at this, we have AB plus BC equals AC, which is true. AB plus BC equals AC. And AB plus BC equals AC. AB is 2, BC is 5, AC is 7. So if you notice, do our values AB and BC equal each other? No. So we just gave a counterexample to this conjecture. AB does not have to equal BC. So again, we just write false. And then this is the last one, and then I'll let you guys go on your own. All right, let's see. If angle 1 is complementary to angle 2, and angle 1 is complementary to angle 3, then angle 2 has to equal, is congruent to angle 3. So complementary angles add up to 90 degrees. We got to remember that. So 90 degrees. So I'm going to draw two angles that are 90 degrees. All right, that's 1. That's 2. Just so I can kind of diagram this. Now, it says that angle 1 is in both of these situations. So I'm going to go ahead and draw my angle. Angle 1. I'm going to say that this is angle 1 here. We'll say that that's angle 1 there, and that's angle 1 there. And what we know about them, since they're both angle 1, they're both equal, so that's congruent. That's congruent to that. They have to be equal. And then they say that angle 2 is complementary to angle 1, and angle 3 is complementary to angle 1. So that means whatever angle 1 is plus angle 3 has to equal 90 degrees. So angle 1 plus angle 3 has to equal 90 degrees. That's what complementary angles are. And how about this one? Angle 1 plus angle 2, they also have to equal 90 degrees. So in that case, notice what's different. Angle 1 plus angle 2 equals 90. Angle 1 plus angle 3 equals 90. So I'm just going to, real quick, I'm going to show you. Angle 1 is the same here and here. 90 is the same here and here. So what's left off is angle 2 and angle 3. They must be congruent. Angle 2 must be congruent to angle 3. So therefore, this one is true. Now, when you do it, if you come across one that's true, you don't have to go and do all that. You can just say true. You don't use an example to prove a conjecture to be true. You only use an example to prove that it's wrong. So it would be a counterexample. I was just diagramming this so that you can see what's going on. But so you guys are going to have these three, or these 4 problems. They're not entirely difficult. A, B, C are collinear. Then AB plus BC equals AC. You're going to determine if that's true or false. So A, B, and C are collinear. But keep in mind, they don't say that A, B, C are in the right order. So that's the key there. They could be collinear, but I could be A, C, B, right? They can be in a line. They are collinear, so that's giving you a little heads up. Maybe you figured out that that's false, but I don't know. Angle R and angle S are supplementary, so supplementary adds up to 180. And angle R and angle T are supplementary. Then angle T and angle S are congruent. Well, that's very similar to this problem right here. The only difference is instead of adding up to 90, they have to add up to 180. So I think I just gave you the answer for that one as well, so you guys can do that one. Excuse me. If angle ABC and angle DEF are supplementary, that means that they add up to 180. then ABC and DEF form a linear pair. So remember, the definition of a linear pair is two angles butted up together that form a line. Their rays form a line. So, but the definition for supplementary angles is it's just two angles that add up to 180 degrees. So I can have an angle here which is, we'll say, 95 degrees, and then I can have an angle here which we'll say is 85 degrees. And what do we have? 95 plus 85 actually equals 180. These two angles are supplementary, but they don't form a linear pair. So that's your counterexample right there. So that one is, you guessed it, false. If DE is perpendicular to EF, then angle DEF is a right angle. Well, that's a definition, and look at your definition of perpendicular lines, and then that will give you the answer there. So, all right, guys, any questions, reach out. Hopefully you guys are enjoying this. This is when geometry starts to get fun, because you're starting to think higher level thinking. So good luck, and reach out if you need some help. Thanks, guys.